Good morning, sir. My name is Sarantaja. I'm from CSC AML second semester. Today, my topic is about isomorphic morphs in graph theory, methods, and algorithms. This presentation explores the concept of graph isomorphing, examining their mathematical foundations, computations, complexities, algorithmic approaches, and driven applications. Graph isomorphic isomorphic is a concept in mathematics and computer science that plays a critical role in understanding the structures identity between two graphs. The term isomorph refers to the property where two graphs are structurally identical despite prob- possibly having different representation or even approaches. In this context, the term unveiling suggests the process of revealing or discovering the hidden structure identities between graphs. Base concept of graphs. At the core, a graph consists of two primary components, vertices and edges. Vertices are nodes. This represents the entity or point of interest in the graph. Edge or link. These are the connections between the vertices representing relationship or interaction. Graph can be directed or undirected. They can also be weighted or unweighted. What is graph isomorph? Graph isomorph is the idea that two graphs, although they may look different, are structurally identical. This means they exist a one-on-one correspondence between their vertices and edges that preserve the adjacent relationship. In the word, two graphs G1 and G2 are said to be isomorphic if there is a bijection between their vertex set. For every part of vertex u comma v in G1, there is a pair u1 comma v1 in G2 such that if u is adjacent to v in G1, then u1 is adjacent to v1 in G2. Formal definition of graph isomorph. Let G1 is equal to v1 comma e1. A graph isomorphic is a bijective function f v1 greater than v2 such that if u comma v similarly e1 belongs to e1, then f of v belongs to e2. The key idea is the graph isomorph doesn't care about the labels of vertices or edges. It's about the underlying structure of how the vertices are connected. Why is graph isomorphic important? Now we are going to see the importance of isomorphic graph. Graph isomorphic is a fundamental concept for many problems in graph theory and computer science. Some of the areas where the concept is particularly important, including pattern recognition. Isomorphic can be used to detect similar structures within different datasets. This is crucial in various fields like bioformats, example, detecting similar molecules, and computer vision. Chemical graph theory. In chemistry, molecules are often represented as graphs, where atoms are vertices and bonds are edges. Graph isomorphs can be determined whether to chemical compounds are identical in structure. Network analysis. In computer network or social network, detecting isomorphic subgraphs can help identify similar configurations or patterns in large scale. Challenges in graph isomorph. The graph isomorph problem is considered to be one of the major unsolved problem in theoretical computer science. Unlike many other problems in computer science, such as sorting or searching, the graph isomorphic problems does not have any effective algorithms that work in all cases. This has led to a deep investigation into the complexity of the problem. While it is not known to be NP computer, it is also not known to be solvable in poly, polymer time of polynomial time of all cases. Graph isomorphism and structure identity. Unveiling the structural identity between two graphs through isomorphism essentially means identifying the deep intrinsic similarities between the graphs beyond surface level difference. Even the graph appears different labels, arrangements, or visual representations. The isomorphism reveals that they have the same underlying structure. This structure identity can be crucial for understanding the properties and behavior of systems represented by these graphs. For instance, chemical structures. Two different molecules have different representations or even different atomic numbers schemes, but if they are isomorphic, they are essential the same compound. Social networks. Two networks may look different in terms of names or other labels, but an isomorphism reveals that their underlying connection, such as groups, relationship, or influenced patterns, are the same. Real world applications. Graph isomorphism has several real world applications where the identification of structural identity is crucial. Graph matching in computer vision. In image recognizing, graphs are often used to represent objects. Matching isomorphic subgraphs help in identifying objects that share similar structures. Bioinformatics. In protein structure comparison, graph isomorphism can be used to detect similar protein structures even if they have different amino acid sequence. Routine in networks. In computer networks or transportation systems, isomorphism helps detect equivalent structures or similar routine patterns. Automated theorem proving. Graph isomorphism helps in symbolic manipulation and reasoning, where the structure of formulas is analyzed for equivalence. Algorithms of graph isomorphism. Over the years, several algorithms have been proposed to solve the graph isomorphism problem. This includes Navi's algorithms. These these try all possible mappings of vertices from one graph to the another and check if they preserve adjacency. This can be computationally expensive, especially for large graphs. Bliss algorithms. This is an efficient algorithm used for graph isomorphism testing, which works well for certain graph classes by exploiting sys- systems. Weisfiller-Lehmann algorithm. This historic algorithm is used for graph isomorphism tests in specific cases, though it may not always guarantee a correct answer. Now coming to the conclusion, graph isomorphism is more than a mathematical, it is a powerful tool for uncovering structural similarities in the variety of fields. By unveiling the hidden identity of graphs, we can reveal common patterns and relationships that may not be immediately obvious. Although the problem remains computationally challenging, it reveals and applications continue to grow. Thank you.